Hey guys, how's it going? So today I'm going to show you how to differentiate a function in three ways. Where I have my typical example here, a typical example, x minus 1 times x minus 2 times x minus 3. And we're going to try three ways to differentiate it. Why did I make this video? It's because I want to show you guys, to verify if you have the correct answer, like one of the ways is to try different techniques, and if you get the same answer for all two or three techniques, you basically know you have the right answer. Like it's like for an example of an ODE, an ordinary differential equation. When you get to that course, you could use the method of undetermined coefficients, the variation of parameters, and the Laplace transform. I think there was one more, but I forget at the moment right now. And if all three of these yield the same answer, then you've got it correct. So let's do it like this. So let's try the product rule first. I'm using the XP pen, so I apologize if this is a little messy. So first of all, when you have I know the product rule applies for two functions, but with a product rule for three functions, it looks something like this. So if it's like d dx f g h, f of x, g of x, h of x, then that's f prime g h plus f g prime h plus f g h prime. And so yeah, let's do that here. So f prime, so then that's x minus 2, x minus 3, plus, okay, so f g prime, so x minus 1, x minus 3, and then f g of h prime. So that goes something like x minus 1, x minus 2. Still getting used to this pen, guys. Oh, we use the mouse again. Okay, anyways, that is equal to x squared minus 5x plus 6 plus x squared minus 4x plus 3 plus, let's see, x minus 1, x squared minus 3x plus 2. And that is thus equal to, oh wait, I accidentally clicked something in my pen. Okay, so that's 3x squared minus 9x minus 12x plus 11. Yeah, I remember now. The second rule is, second thing is something called logarithmic differentiation. And once I'm done here, I'll do a video on logarithmic differentiation right now. Logarithmic differentiation. Okay, so let's just draw a big line here to separate our work. So the way with logarithmic differentiation is like you take the natural logarithm of both sides of the equation, and then you differentiate it like such, then you convert it back to y. So let me show you how it works here. So just y is f of x, right? So just say y is equal to x minus 1, x minus 2, x minus 3. Okay, so y prime is thus equal to, okay, no, actually, you know what? Let's do it like this. So let's take, like I said, the natural logarithm of both sides. So ln of y is equal to ln of this stuff, right? Okay, and now let's take the prime of both sides. So I'm just going to directly do a prime here. worth differentiating with respect to x, right? So y prime over y let me think. Y prime over y is equal to, is equal to ln, so taking the derivative of this, right? So let me think right now. Yeah, okay. So x minus 2, x minus 3 over x minus 1, x minus 2, x minus 3. Plus, okay, and then we're taking the derivative of this. I'm using the product rule for 3 functions right now. So then that is x minus 1, x minus 3. All over x minus 1, x minus 2, x minus 3. Plus x minus 1, x minus 2. Over x minus 1, 2, and 3. All right, so y prime over y is thus equal to okay. So basically we have x minus 2. So then here it's just 1 over x minus 1, right? Plus, and then here everything cancels out except x minus 2. So that's 1 over x minus 2 plus 1 over x minus 3. All right, and then we multiply both sides with y, or y primed is equal to all this and y is x minus 1, 2, and 3, right? I'm going to put a caps here and say that equals y. And when you expand that, that is equal to, let's see, so the first part is x minus 2, x minus 3, because the x minus 1s cancel out. And then plus x minus 1, x minus 3. And then plus an x minus 1, x minus 2. And that basically is the exact same thing we have here when we did the product rule. And if you want, you can just say that's 3x squared minus 12x plus 11. Okay, so that is also correct. And the third way is by direct expansion, if you're not afraid of large numbers and things getting messy. This is what I call the cheating way, the really simple way. If these functions were any more complicated, you could not directly do this. So the idea is you just directly expand it out and then just use the product rule in all essence. F of x is equal to f of x is equal to what should we call it? So x minus 2 times x minus 3 is x squared minus 5x plus 6. You could do the product rule with x minus 1 and x squared minus 5x plus 6. I'm not going to do it. In fact, you can do it as an exercise for yourself to hone your derivative skills, but I'm just going to directly expand this out. Let's use FOIL. So x times all this is x cubed minus 5x squared plus 6x minus x squared plus 5x minus 6. And that, yeah, okay, so that's f of x. So you know what? We can simplify this. So that's x cubed minus I think that's 6x squared plus 11x minus 6, and just to directly take the derivative of this. And f prime x is equal to 3x squared minus 3x squared minus 12x plus 11. So all three of these work. It's good. So basically the moral of this video was just to show you that it's nice to know different techniques, because like, you know, when you're doing, sometimes when you're doing like questions that don't have a solution in the textbook, or like, you know, you don't have, like, because one of my textbooks, they only give you the solutions to the odd numbered questions. And maybe once in a while you want to do some extra practice, so you do the even questions, but they don't have solutions. In that case, use different methods. And if they all give you the same answer, it means you're doing something right, most likely. Yeah. So that's all good. Let's now do one final thing about logarithmic differentiation. Diff or differentiation. So basically, logarithmic differentiation, you've already seen this. Let's use it for a more like, you know, something you haven't seen before, a function like y equals x to the power of x, and you're asked to find the derivative of this. Here is the wrong way to do it. Believe me, I've done this before. Okay, so you basically apply the power rule to x, and then you basically bring it out front. Okay, so you basically, yeah, you apply the power rule, and then you say that's x times x, and then x minus 1. Wait, let me see if you could, yeah, and then say it's x squared times x to the power of x. That is a big fat wrong. The reason why this doesn't work is because the power rule, like for y equals xn, that the power rule only applies when the n, that exponent, is constant, but here the exponent is not constant, so it doesn't work. So what you do instead is logarithmic differentiation. It's the only way you could do it. So yeah, so basically, I remember when I was like doing math, learning math, whenever something didn't seem right, like not just math, in any class, I would say, oh, there's a contradiction. I found a contradiction. And then I remember my law teacher one day was like laughing. He's like, your contradictions tend to be misunderstandings. Like, you know, the world of math has not been corrupt just by a 22-year-old kid doing homework, right? So yeah, basically take the logarithm on both sides. So ln of y is equal to ln of x to the power of x, which, as you know, you can bring the exponent out to the front, which is x ln x. Take the derivative with respect to x. So y prime over y is equal to ln x plus, let me think. So that's when you take then x times 1 over x, which is ln x plus 1. And before we go any further, so like ln ddx, so like when you're doing implicit differentiation, and with another variable, what you do is you treat this variable like x. So you treat it like x. So just think of your differentiating with respect to ln x, except there's a y here. And that's 1 over y, but then you say dy dx. And this works basically every time when you do implicit differentiation for any function, in essence. well, yeah, let's just erase this part. So then, yeah, y prime is equal to ln x plus 1. Y, which is equal to x to the x ln x plus 1. Sorry, yeah, that's the answer right here. All right, so that was all I wanted to share for you guys today. Yeah. So I really hope you guys like this video. I'll keep posting more. I'd love to stay, but for now, I gotta jump. I'll see you guys on the other side of the bridge. Catch you next time.